All right, we're going to look at graphing exponential and logarithmic functions in ALEKS. And so this first function that we have, it's a 4 to the x, which is an exponential function. So when I'm looking at my possible tools over here, I have the exponential graph, which is highlighted right here, and then the other one's the log graph. So those are going to be, again, like some parent functions that you want to make sure you know. And so to use this little tool here, it wants me to first place a horizontal asymptote, so I do that, and then it wants me to plot the first point. And so that's not where I want it, so let me erase that. And so I'm going to actually plot my points by using the pencil, or not pencil, but the coordinate tool. So I want to plot 0, 1, because if I plug a 0 in for x, that gives me an output of 1. 0 exponents always equal 1. That's why this point is on all exponential functions, and then sometimes shifted. And then I like to plug in a 1. A 1 would get me a 4. So I'm going to plot that point, and then I'm going to use the tool. So I'm going to X out of that, and that's going to be my tool. And so it already starts right there. I put my horizontal asymptote, so I can just click. I clicked on it, and it's on the x-axis. So all the time, your horizontal asymptote is going to be on the x-axis, because if you have an exponential function, there's no way that it can be negative outputs or 0 output. So we have that horizontal asymptote unless there's shifting. And the only shifting that we're talking about is if it vertically moves up or down. So that would be like plus something outside of this 4 to the x. So I'm going to place my points on those 2 dots that I labeled. And there's my second point. And so there's my sketch. That's 4 to the x. I'll check it, make sure that's good. And there's my graph. And then it wants me to state the domain and range. The domain of this function is going to be negative infinity to infinity. So negative infinity to infinity, because it goes left and right forever. And then the range, it's restricted by that horizontal asymptote. So it's going to be from 0 all the way to infinity. And we'll check that, make sure we're all good. Okay. So for question number 2, it's going to ask us to do the same thing, but it has an exponential function where the base is a fraction, like 1/5 here. And so similarly, we're just going to click on the coordinate plane here to plot our points. So again, if I plug in a 0, it's going to get me 1. So I plot that guy, plot that point. And then when I put a 1 in, that's going to get me a 1/5. So I plot that point. And so you can see this one's going to go like decreasing compared to the previous one. So I need to get my sketching tool, and I'm going to put my asymptote right on the x-axis again because it hasn't been shifted. I'll plot my first point, my second point, and it's going the orientation that I need. So again, you click on the tool, and then the horizontal asymptote will be on the x-axis. I push check, and we did it. Again, it asks us for the domain and the range, so you could write that. If I skip on over to part 3, this gets a little bit more interesting because there's been a transformation. So we have the regular 4 to the x function, so that's our exponential function. That looks like that kind of J shape. But then that plus 3 is outside of the exponential function, so it's going to add 3 to all of our outputs, which really shifts the entire graph up 3. So to use transformations, we're going to say that the graph is shifted 3 units upward. And then it continues on, and it says the parent function y equals 4 to the x is an increasing function. So when that base is 4, a number bigger than 1, it's going to go up, 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 because it's taking 4 to an exponent. It's going to grow and grow and grow. Compared to when we had the fraction, it was decreasing. It was like backwards J. So we're increasing. And if we want to plot a few points, you can see that if you have a -2, if you plug it in, 4 to the -2, a negative exponent means reciprocal, and 4 to the second is 16, so that's why it has 1/16. So now if we are making the entire graph move up 3, it's going to have to add 3 to this y value. So you can write it as 3 and 1/16, or as an improper fraction, that would be 49/16. Then it says, okay, well, if you plug a -1 in there, you're at 1/4. And again, that should make sense because a negative exponent means reciprocal. 4 to the 1 is 4, so it would be 1/4. Now, if you're adding 3 to all of our outputs, that would be 3 and 1/4. So you can write it as that mixed number, or it's going to be 13/4. That's why they have that there. So then if we look at plugging in 0, 1, 0 plugged in, 4 to the 0 is 1. So this would correspond to, well, if we're shifting all our y values, up 3, it would be 0 here, and if we add 3 to the 1, that would put us at 4. If I put a 1 in, 4 to the 1 is 4. And so now when I put 1 in, it's going to go up 3 more, which would be, instead of 4, it would be up 7, since 4 plus 3 is 7. When I put a 2 in here, 4 to the second power is 16, but now I'm adding 3 more. So now when I put a 2 in, I would be up at 19. So that's point-wise, and then that will help you also with your graphing. So if I'm going to graph this guy, I just got to plot those points. So remember, the exponential function needs a horizontal asymptote. It has shifted up 3, so its horizontal asymptote is going to be up at y equals 3, and then I also need some points. So I already have some points up here. I'm going to put 0, 4. So it used to be 0, 1, now it's 0, 4 because I shifted up 3. So plot that point. And then I'm going to put the point 1, 7. So again, normally I plug a 1 into 4 to the x and I get 4, but I'm adding 3 to those, so I'm going to have that. So there's my 2 points. I'm going to get my tool, place my horizontal asymptote, plot the points. I'm just clicking on each of those dots, and so there's my graph. And we'll check that. Oops, that's what I forgot. So the horizontal asymptote shifted up 3. So let's try that one more time. The horizontal asymptote would be here now. So my first point was there and there. So let's fix that and erase the other graph. All right, so again, what I did is I had my horizontal asymptote at y equals 3. I'm not erasing it. And I had my points at 0, 4, and 1, 7. So that should be all good now. Perfect. And my domain is still -infinity to infinity, and the range, the lowest I can go is really close to 3, so my range is going to be 3 all the way up to infinity. And we'll put that one in here too, just to make it all complete. And so we got it. And so the equation of the asymptote, because we had the vertical shift, it's going to be at y equals 3. Make sure you put the y equals because it is a horizontal line. We check that, and we got it. All right, let's look at number 4. This is going to be graphing using the transformation. So they already have the exponential function here, and so all we need to do is use the transformations to graph. So this +1, that's just like the 3 we just had, is shifting the entire graph up 1 space. And then this +4, it's inside the function, it's going to be doing the opposite of what we'd expect. So it's going to move left 4. So let's see if we could put this on here. We're going to move it up 1, and we're going to go left 4. So 1, 2, 3, 4. And so it looks like my asymptote is at 1 now, and then the main point that I like to check is 0, 1. If that shifts up 1 space, it would be at 0, 2. And if it shifts left 4, 1, 2, 3, I need to move over 1 more. And so we're at -4 would get us a 2. And you can also check it into this equation. If I plug in a -4, -4 plus 4 is 0. 4 to the 0 is 1. 1 plus 1 is 2. So -4 should be on there with 2. Let's check that. And we got it. All right, and then it continues on with the domain and the range, which the domain would be -infinity to infinity. And our range, because of this little +1 at the end, will be from 1 to infinity. 1 would get a parenthesis. And the equation for our asymptote would be y equals 1. So again, make sure that you type in y equals 1 for that. All right, let's try another graph. So this time it took our 4 to the x function, which is, again, sketched here already for us. We want to use transformations to graph it. That negative is outside in the front, so that's going to reflect the entire thing over the x-axis because it's going to make all of our outputs negative. So it's going to go down that way. So we're going to click on the reflection button, and there we go. We got that. And that's it. There's no shifting up, down, left, or right, so we'll just check that we're right with that little flip. And we got it. The domain is -infinity to infinity. Now this time the range, it's going to go down forever. So we're going to say from -infinity up until 0, because it will get really close to 0 and not touch. And the the horizontal asymptote is still at y equals 0. All right, so let's look at another one here. So now we have our basic function here is 1 over 5 to the x power. So because we see that fraction less than 1, that's why it's a decreasing backwards j. And we got to see what these other values are doing. This minus 3 is going to take the whole graph and shift it down 3. And this negative is going to reflect it. So I'm going to reflect it so that way we can see all of our outputs from this 1 over 5 to the x all change negative. And then they're going to go down 3. So we're going to take this, and we're at 0, negative 1 right now, so we're going to go down to 0, negative 4. And if we want to make sure that 0, negative 4 is on there, I always like to check that 1 point. If I put a 0 in, 1 to the 5th to the 0 is 1. So we'll have negative 1 minus 3, which is negative 4. So 0, negative 4 is on there. That looks like it should check. Perfect. All right, let's just try one more for fun here. We have the e to the x minus 2. So you can see e to the x has already been graphed here. So minus 2, it's inside the function. That's just going to shift us to the right 2 spaces. So again, I like to take one main point like 0, 1 and move it to the right 1, 2 spaces. There's no up or down movement, so our asymptote is still at y equals 0. And we got it. I would like to look at one more log function. These are still all the same, just kind of move them around with that transformation tool. And so if I look at this function y equals log now, base 7 of x, I know already that I'm going to be kind of this backwards way. Because the exponential function shoots upwards, we are talking about its inverse function, so it's going to flip the other way. It's a reflection across the line y equals x. So I already know that if I put the point, like I want to think about its inverse, which is 7 to the x. So if I put a 0 in for 7 to the x, 7 to the 0 power would be 1. So 0, 1 is on the exponential function. And if I put the point 1, or x value, into 7 to the x, 7 to the 1 is going to be 7. So on the exponential function, I know 0, 1 is on there, and I know 1, 7 is on there. So I'm going to plot 1, 0 on my inverse and 7, 1 on my inverse. Now as I read this, it says plot 4 points. So again, it's much easier not to plug into log, but to think about 7 to the x. It's inverse. So again, if I'm thinking about 7 to the x, I would plug in maybe a negative 1. 7 to the negative 1 power is 1/7. So again, the inverse would have 1/7 with negative 1. And I'll plug in one more, about a 2. 7 to the second power is 49, which means this inverse would be 49, 2. So again, to plot the points on here, I would have not 0, 1 anymore, but 1, 0. So I would plot that point. I would have not 1, 7, but 7, 1. And I would have 1/7 with negative 1. And then I would have 49 with 2. Okay, so it says that point's out of bounds. Oh, darn. So you can see that the grid only goes up until 9. So we're going to have to choose something smaller. So what I would do then is instead of negative 1, I would use negative 2, which is getting me 1 over 49, because that negative is a reciprocal. So that means 1/49 would get me negative 2. So I'm going to put in 1 over 49, and that goes with negative 2. Again, this is the backwards, like we're flipping our x and y, because normally if this was an exponential function, 7 to the x, 7 to the negative 2 would be 1 over 49. So I'm just flipping my x and y. So I plotted that point. So you can see those 4 dots are making my logarithmic function. I also need to plot my asymptote, which is on the y-axis, because I don't have any values going over to the left side, because again, it's the inverse of our exponential function, which didn't have any values going down below the x-axis. All right, so I'm going to connect the dots, and so it already has my 4 points drawn perfectly, and so we just connected them. And I check, and we got it. So I hope that helps a little bit with the graphing. If you need any more help, just post it in the student lounge or send me an email.